Tired of manual testing feeling like endless clicking and documentation? Stop wasting time. We're about to show you how to perform AI-augmented zero-code manual testing using Playwright MCP and GitHub Copilot, all inside VS Code. Get ready to generate reports, execute tests, and track defects automatically. Let's jump in.
Let's start with today's demo. This one is on how to use the Playwright MCP for manual testing, how we can do our manual testing inside Visual Studio Code by using Playwright MCP and GitHub Copilot. For this, we need Visual Studio Code installed on our system. In VS Code, we'll set up the Playwright MCP server and GitHub Copilot. Normally, in VS Code, we go to Extensions and simply search for GitHub Copilot. Here, we can see the extensions GitHub Copilot and GitHub Copilot Chat. We can install both from here. They give us an install option. On my system, both are already installed, so they show up under the installed section. After installing GitHub Copilot and GitHub Copilot Chat, how do we confirm they're set up? Just go here and you'll see an option, Open Chat. When we click it, the GitHub Copilot Chat panel appears. Our LLM agents are available there. You can choose any agent like Claude Sonnet, GPT-4, Gemini Pro, etc., and give our instructions to GitHub Copilot through them. Now that GitHub Copilot and GitHub Copilot Chat are installed, we need to configure Playwright MCP. Playwright MCP is the bridge between GitHub Copilot and the human language instructions we give. To convert our simple instructions into actionable commands, we need this bridge, the Playwright MCP server. We'll just go to Google and search for Playwright MCP server. You'll see the official repository. Open it and you'll find a simple option, Install Server in VS Code. Click that. A pop-up will appear asking to open Visual Studio Code. When we click it, the extension page opens in VS Code and we click Install. I've already installed it, so it shows up under my MCP Server installation section. You can see MCP Server installed, where my Playwright MCP is installed. At this point, Playwright MCP is only added as an extension. We still need to configure it. In GitHub Copilot Chat, there's a Configure Tools option. Click that. You can see Playwright MCP Server, and under its settings, the configuration JSON. You'll also see they provide 21 tools. From here, we can start, restart, or stop the server. When I start the server, how do I verify it actually started properly? Open the terminal. In the output, you'll see connection state starting, then connection state running, and 21 tools. From here, we can also stop or restart it. They've said Playwright MCP has 21 tools. These are already built in, and we'll be using them for our manual testing. I'll show those 21 tools. Simply go to Configure Tools, expand Playwright MCP, and you'll see all 21 tools we're about to use, with simple commands and their functions. Now our setup is ready. We have GitHub Copilot, eCamera Chat, and Playwright MCP. We'll send our instructions in plain human language, in English or any language we understand, to GitHub Copilot. Copilot will convert them into Playwright MCP commands and perform the actions. Let's move to manual testing. In manual testing, our first task is exploratory testing, where we first understand the application. Traditionally, we'd paste the URL into a browser, then drill into each module/feature to explore and understand the application's functionality. Here, we'll use Playwright MCP to do all this. I've already created all my prompt files, so we can simply copy-paste or attach the files directly into context. Our first task is exploratory testing. For demo purposes, I've picked the Demo Blaze site, which is an e-commerce site. You can see for exploratory testing, I've written a simple prompt. Navigate to the Demo Blaze site using Playwright MCP server for exploring the module. We'll provide just one module name for now, and it will explore that module and later generate an exploratory testing report. Since this is an e-commerce site, we'll explore the Add to Cart functionality. We'll tell it to explore the Add to Cart module. We don't even need to copy-paste. We can attach the prompt file directly and say, follow the instructions given in the context file. A simple human language instruction like follow instructions attached in context, in simple English, is enough. When I send that, Playwright MCP comes into the picture. The MCP/agent analyzes which Playwright MCP command to call, converts our English instruction into a Playwright MCP command, and takes full control of the browser. Based on the Add to Cart functionality we mentioned, it begins exploring. You can see it first clicked the phones category, picked a sample product, and added it to the cart. It will go into every category, add products, explore the flows, and later generate the exploratory testing report. It also navigates to the cart page to verify that the product was added. We can see the exact actions it's performing right in the chat. It also captures snapshots of each page. When it creates the exploratory testing report, it uses these explorations as the basis. Everything it explored is included. You can see it's trying all sorts of possible actions, like delete functionality, etc. Anything it determines could be relevant. The browser is under MCP's control, so it can access and automate everything. In traditional manual testing, we'd go to each category and add products one by one, which takes a lot of time. Here, we can kick off the execution and come back later just to review the report. Now, let me create the exploratory testing report. I'll ask it to create the report in the manual testing documentation directory. It will generate the report based entirely on what it explored, listing categories, features, products, etc. For example, you might see a file like exploratory_testing_report.md. In the summary, it might say something like, Add to Cart works reliably across different product types, and so on. We'll review and save it. After exploratory testing, we design test cases based on what we learned. Since the browser was fully explored, the agent knows the test steps, test case count, priorities, etc. We'll simply ask it to design the test cases. I've kept a simple template for test case design, which we'll attach in the context and say Generate Test Cases. It will generate comprehensive test cases for Add to Cart in CSV format, following the template I provided. We can change this format as needed. IDs, names, steps, expected results, priorities, etc. are all adjustable per requirements. You can see it generates the test cases for the Add to Cart module based on the Exploratory Testing Report, IEE, using that report as reference, not just imagination. It produces many test cases. CSV can be harder to read, so I'll open it in Excel to show you. You can see the test name, step number, expected result, etc. And those expected results are based on what it explored. Now our test cases are generated. Next, we need to upload these test cases into our test management tool. Traditionally, we would open the tool and add test cases one by one. If there are a dozen cases, that alone can take at least an hour or more. But we have a simple solution. With a single command, we can upload all 12 test cases to the test management tool. I'll skip walking through every case here, but to upload, we attach the CSV file in context, provide the organization and project names, e.g., people for this demo, and ask it to create the test cases using the instructions in the context file. It will read the CSV and create the test cases in the test management tool. Now you can see it returns links for the created test cases. I'll open one, say test case ID 142, to verify the upload. You can see the test steps, test data, and actions. All of it is created exactly as in our CSV. So with a single line, we uploaded all the test cases. After designing test cases, we need to create a test plan for execution. I have a test plan prompt /template ready. I'll attach it in context and say, generate the test plan. You don't even have to say, follow instructions. If the prompt is attached, it follows that context automatically. It generates the test plan, EEG, in the same documentation directory. You can change the test plan format as you like. There's no restriction. The important thing is to keep instructions simple and clear. LLM agents follow the prompt exactly. If you provide a specific format, it will adhere to it. Otherwise, it will use reasonable defaults. You can see it generated the test plan with details like project name, module, add to cart, and more. Now I want to upload this test plan to the test management tool. I'll give a simple command. Create test plan, along with my project and organization names, and attach any required fields, like issue type, fix version, etc., depending on the tool. It will upload the entire test plan. We can see it created a test plan and returned an ID, say TP20. Our comprehensive test plan for Add to Cart in the e-commerce app is now uploaded to the test management tool. Next, we need to add test cases to the test plan for execution. I'll instruct it to link the test cases provided in the context, our CSV, to the test plan TP20. We drag and drop the CSV into context and allow the tool call. It confirms. I have linked all the test cases from the CSV to the test plan, with a summary and a link. We'll verify by refreshing the test plan in the tool, and looking under the Tests section, you can see all 12 test cases are now linked. Doing this manually the traditional way would have wasted a lot of time. Here it took just one line. Now, we need to execute the test cases. This is where Playwright MCP really shines for manual execution, because traditionally, we'd have to follow each and every step manually. We'll attach our test execution prompt in context and tell it to use Playwright MCP to navigate to Demo Blaze and execute the test cases. We have 12 test cases, but for demo purposes, we'll execute just one. So I'll give the test case ID, e.g., execute test case TC001. You can see it executing. It launches the browser, verifies the home page loaded, picks the product specified in the test data, adds it to the cart, and follows the exact steps defined in the test case. It handles browser dialogues, alerts, automatically via MCP. Then it navigates to the cart to verify the product was added. It completes the 7 steps successfully and then creates a test execution report. We can generate this in any format, .md, .txt, etc. The report shows overall status, execution start time, each step with pass/fail, and actual results. It also saves a JSON file with the result details, status, and actual results for each test case. Now, we need to update the results in the Test Management Tool's test execution. Initially, it might show 0 passed/0 failed. We need to update the step-level results there. So we'll ask it to update the test step results. and we'll attach the test execution report as evidence. We also provide the organization and project names for reference. It will use that to update the pass, jaw, fail counts and the step details in the target execution, say execution ID 18. Sometimes it may discover multiple executions under the test plan and choose the most recent one. It then updates step results for the relevant test cases. After it's done, we refresh and see, for example, 2 passed/0 failed. If we had executed 2 cases, we can also drill into a specific test case to see that all 7 steps passed, with expected versus actual results filled out for each step. Now, what if a test fails and we need to log a defect? In our demo, both test cases passed, so we'll intentionally create a failure to demonstrate defect reporting. I'll change the product name in the test data to something invalid, so the test will fail, and then ask it to execute the test case and generate a defect report. I attach the test case and the defect report prompt to context and ask it to run only the first test case, again to save time. Since we intentionally used a non-existent product name, e.g. iPhone 17, it won't find it. The execution runs MCP navigates, and when it can't locate the product, the step fails. When a defect occurs, it generates a defect report and stores evidence, screenshots, logs, in the MCP output folder, e.g. under a data/local MCP output path. We can use that evidence for the defect. That's the overall Playwright MCP demo for manual testing. As you can see, using Playwright MCP saves a lot of time. It takes control of the browser, executes flows, handles documentation, and gives us reports. Thank you.
And that's how you streamline your entire manual testing process using Playwright MCP. If you found this zero-code workflow valuable, hit that like button and subscribe for more AI and QA deep dives. All the tools and links you need are down in the description. Go set up your AI-augmented environment today. We'll see you in the next one.